Welcome to the deep dive. We take a pile of sources, pull out the key insights, the really surprising bits, just for you. Think about it, trying to understand these invisible radio waves carrying our signals with, sunspots flaring up and geomagnetic storms messing things up. We're all drowning in information, right? But what if you could get a shortcut? A way to be genuinely clued in on something complex without getting totally overwhelmed. Well, that's exactly what we're doing today. We're diving into the really fascinating world of radio wave propagation, specifically what was happening back in June 2025. Our mission here is to unpack the critical stuff from our source, Propagation Trends in June 2025.pdf, and just give you the clear picture. Whether you're maybe an amateur radio op-ed trying to bag those rare contacts, or a pro communicator needing reliable signals, or maybe you're just, curious about these unseen forces, understanding these trends matters. It's kind of a shortcut to getting informed on a niche, complex topic that honestly affects global connections more than you might think.
It really is fascinating, isn't it, how events happening millions of miles away on the sun directly mess with our communications right here on Earth. When we talk propagation, we're essentially watching this dynamic dance between solar energy and our planet's atmosphere, the big players. Well, you've got geomagnetic activity, that's Earth's magnetic field reacting to solar stuff, and solar flux. Think of solar flux as like a daily grade for the sun's radio output. These factors really dictate how well signals travel, especially for long-distance stuff, what hams call DX.
Ah, DX, right. The challenge of talking across continents.
Exactly. And different radio bands, like HF high frequency, that's your globe hopper, or VHF. Very high frequency, more regional. Usually they all react differently.
Okay, so let's jump into early June 2025 then.
Yeah.
What are operators facing right at the start of the month? Was it a smooth ride or something else?
Oh, it definitely started with a bang. And not really a good one if you were interested in HF. We saw pretty significant geomagnetic unrest. This was mostly thanks to a big coronal mass ejection, a CME, basically a huge blast of solar wind and magnetic fields that erupted back on May 31st. That was followed by this rush of high-speed solar wind, and it pushed the KC index way up. It hit around 7.7 on June 1st.
7.7, wow. So the KP index measures that geomagnetic disturbance, right? 7.7 sounds pretty intense.
It is. It basically means Earth's magnetic field was getting seriously hammered by the sun. A major disturbance.
So for anyone trying DX, those long-distance signals, sounds like they just sort of vanished. How fast does that happen? Can you even see it coming?
It can happen incredibly fast. And yeah, for operators, this slammed the maximum usable frequency, the MUF, down below 14 megahertz on lots of long paths. This isn't just a small glitch. I mean, imagine someone just cutting a global internet cable over and over for days. That's kind of the impact for HFDX when the MUF tanks like that. Whole continents just become unreachable on certain bands. Plus, the solar flux index, the SFI, it dropped too. Went from about 164 down to near 134. And the other geomagnetic indices, the ANK indices, they were all over the place. Erratic.
Huh. So real instability, a very turbulent start for HF then.
Definitely.
But interestingly, the source mentions that while HF was taking a beating, there were strong sporadic events around June 6th. It says 6 meters sounded like 20 meters. That's quite a description.
Yeah.
How can one part of the radio spectrum be thriving when another is just dead?
Yeah, it really highlights that contrast. It's almost like a seesaw. Solar activity knocks down HF, but maybe completely different atmospheric things boost VHF. Sporadic E, well, the name kind of gives it away. It's irregular, but often gives these really strong signals on VHF bands. What happens is you get these dense patches of ionized gas forming up in the E layer of the ionosphere. They act like these temporary super mirrors for radio waves. And in this case, early June, it was pretty regular and seemed linked to weather patterns like jet streams. A surprising bonus, really.
Okay, so early June.
Yeah.
Tough for HF, but saved by sporadic E on VHF.
Got it.
So heading to mid-June, were people breathing easier? Did things finally settle down, or was it still a fight?
It was mixed. The solar flux did bounce back, climbed up to around 150. That was actually better than NOAA predicted. They were thinking maybe 120, 130.
Oh, interesting. So more solar energy.
Yeah. Right, but the geomagnetic conditions, still shaky. The K-Dave index spiked above 5 around the 14th. This time it was linked to coronal holes reappearing on the sun. These are like open doors in the sun's magnetic field, letting high-speed solar winds stream straight towards Earth.
Coronal holes, okay. So even with better solar flux, Earth's magnetic shield was still getting pummeled.
Exactly. So still causing disruptions, even with the higher flux number.
And how did that translate for those HFDXers? Still mostly static.
Yeah, HFDX was still pretty sparse on the main bands, like 20 and 17 meters. It wasn't completely dead, though. Despite the tough conditions, there were these occasional, very brief openings. Paths popped up to places like South Africa, South America sometimes.
Fleeting windows then. You had to be listening constantly.
Pretty much. You had to be really persistent, very opportunistic.
But sporadic E, that kept being the reliable performer, the silver lining.
Absolutely. High season sporadic E just kept delivering. Multiple short skip openings, especially good for mid-latitude VHF. Again, often linked to those jet stream positions, usually morning and then late afternoon peaks. It was definitely the star player for VHF during that period, made for reliable, shorter distance contacts when HF was just so difficult.
Were operators using any other tricks up their sleeve, any other ways to get signals through during this time? Because, hams get creative in tough conditions.
They certainly do. Meteor scatter, for example, that helped out on 6 meters, 50 megahertz, especially early in June with the Araidids and Zeta Perseids meteor showers peaking.
Meteor scatter,
Or
like bouncing signals off shooting stars.
sort of off the ionized trail they leave. It's a tiny fleeting reflection high up, but sometimes it's just enough to ping a signal over the horizon for a second or two. Very quick bursts. We also saw some troposcatter or tropo. That relies more on weather conditions, like high pressure systems. Often happens later at night or early morning. Lets signals bend over the horizon a bit.
Right. And what about the really ambitious stuff like EME or Moon Earth, bouncing signals off the moon itself? That sounds incredibly difficult.
It is a serious challenge, technically. And conditions weren't great for AME around June 11th to the 15th. The moon was at apogee, then its furthest point from Earth. That means a longer path, weaker signals, just makes an already hard thing even harder. Things did improve slightly around the 21st, 22nd as the moon got closer again, but generally mid-June wasn't prime EME time.
Okay, so as June started wrapping up, say the 16th to the 30th, did things finally calm down, or was it just more the same unsettled pattern? June 2025 is sounding less like a relaxing summer month and more like radio boot camp.
You're not wrong. Solar activity stayed moderate, really, through the end of the month, but those recurrent coronal hole streams, they kept coming back. So we continue to see these periods of unsettled to minor storm conditions right up to the end of June. Still a bit choppy for the ionosphere.
But I'm guessing sporadic E just kept shining, the reliable workhorse.
It really did remain the absolute highlight, especially in 6 meters, but also helping higher bands too sometimes. It was very much driven by those typical summer atmospheric patterns, just provided consistent chances for operators, at least over those shorter paths.
So with all this going on, the storms, the brief openings, the sporadic E, how did operators actually do? Because June wasn't just about physics. There were some major de-expeditions happening.
Yeah.
Tell us about V-73WW from the Marshall Islands.
Yes, that was a really big one. They put out their report mid-June, and the numbers were impressive. Almost 104,000 contacts, 103,864 QSOs to be exact,
Wow.
over just 14 days. And remember, they were battling those conditions we just talked about. They worked across CW, SSB, RTTY, FT8, all the main modes. And the Marshall Islands, that particular spot, IOTA OC029, it's a pretty rare one. Number 96 on the most wanted list at the time. So getting them in the log was a big deal for a lot of people.
A huge achievement then. And CN2DX from Morocco was another notable one.
Yep. CN2DX popped up on the DX clusters in June, too, operating out of Kenitra, hitting bands from 40 up to 6 meters, CW, SSB, FT8 again. They were quite active mid-month and planning to stay until the end of July. And we also saw TY5FR from Benin start up around Juneteenth. These de-expeditions are vital, for giving people a shot at rare countries. And the teams face immense challenges, logistics, equipment, and trying to figure out the propagation.
Right. But connecting this back to the conditions, the report notes that even with these exciting stations on the air, the HF pileups were actually quite thin. That ties directly back to those MUF limits, doesn't it?
It absolutely does. The propagation just wasn't supporting huge signals over long paths consistently. Those restricted maximum usable frequencies we discussed. It meant that even though these were highly sought-after stations, fewer people could hear them well enough at any given moment to call them, so you didn't get those massive chaotic pileups you sometimes see. It was thinner, more manageable, which is actually a direct reflection of how tough the conditions were.
So, okay, conditions are tough, pileups are thin. How did operators even know when and where to listen? This is where it gets really interesting. You mentioned the tech. The source highlights tools like dxsummit.ifi and dxlook.com really taking off.
They became absolutely critical. These are live cluster tools. They aggregate spots reports from other operators saying who they're hearing. But they also pull in data from automated systems like WSPR and PSK Reporter, showing actual measured signal paths in real time. And they visualize MUF data. So instead of just guessing, operators could see right now where signals were actually propagating. It's like having a real-time map of the ionosphere crowdsourced, hugely powerful for adapting on the fly.
And prediction tools like VOA Cap were still important for planning ahead.
Oh, definitely. VOA Cap is fantastic for longer-term planning. You feed it the solar data, tell it the path you want, and it gives you a prediction of the probability of that path being open at different times and frequencies. It helps you figure out, okay, maybe my best shot for South America on 20 meters is likely to be around this time tomorrow. It aids that tactical planning enormously.
Okay, so pulling it all together, what does this mean for you, the operator, trying to work stations during a month like June 2025? What were the key tactical takeaways?
Well, if we connect this to the bigger picture, it really underscores how crucial it is to adapt your strategy based on what these natural forces are doing. You can't just stick to one plan. For HF, the advice was pretty clear. Be ready for very short DX windows, especially on 20 meters. And really focus on leveraging that sporadic E. Don't forget 17 meters either. It sometimes surprises people.
Right, be opportunistic there. And for VHF, which seemed to have the better time overall.
Yeah, for VHF, working 6 meters via sporadic E and even meteor scatter was really the top strategy. That was the most consistent action. It also meant paying attention to VHF contests, especially on 2 meters, and actively hunting for those tropo openings whenever high pressure settled in.
And for the EME folks, it was all about timing, being aware of those brief moon windows early on, and that slight improvement later, around the 21st, 22nd.
Precisely. And underlying all of that was the tech piece. Use VOA CCAP to plan, use the real-time cluster tools to see what's actually happening now, spot those openings, find those thinner pileups. It's that blend of understanding the science and using the tools effectively.
So stepping back, what does this all mean for us, maybe even beyond the radio hobby? This whole deep dive into June 2025's radio weather, it really shows how much these huge, unpredictable solar events affect global communication, and how critical planning and using the right tools become. It's kind of a stark reminder, isn't it? That even with all our digital tech, we're still deeply connected to and sometimes at the mercy of these powerful, invisible natural forces. It raises a bigger question maybe for all of us. How does understanding these forces, solar winds, magnetic shifts, change how we view the resilience or maybe the fragility of our superconnected world? Think about it. This detailed data, the ability to predict and adapt to natural cycles that radio ops use for timing. How could that kind of knowledge, that kind of strategic adaptation be relevant in other areas? Other fields that depend on global links or precise timing? It's definitely something worth thinking about.